Welcome, everybody. We're going to be working on chapter 3 today, which starts to cover decision statements, or what we call selection statements, also known as if-else statements in Python. And I'm taking us first to the W3 schools section for the Python language, where they talk about if-else, because I think they have a really nice, concise little page here that talks about kind of the primary aspects of this. So the first thing that we have to think about, once again, is when we're dealing with programming code, we have those three ways that we solve logical problems. One is step by step. The second tool that we put in our bag is decision statements or selection statements, which we're about to learn. And the final one is repetition. So this covers decision or selection statements in the form of if-else. But before we can write an if-else statement, we have to know what the comparison operators are. So we can write code that checks for true and false, right? So this is kind of the primary aspect of this technology. So one thing that we often do, and they have some kind of simplified statements here, so I'm going to just kind of zoom in just a little bit here. They talk about things being equivalent. Now, in the Kahoot that we did earlier, we talked about this. If you see a single equal sign, that's an assignment statement. That's assigning the value of one thing into a variable. When you see two equal signs, that checks for equivalency. That's the mathematical equivalence of a single equal sign, right? So what that statement says is A equivalent to B? If we want to check to see if they're not equal, we use the exclamation point instead. But with all the other comparisons, we use standard mathematical notation, which is less than or equal, greater than or equal. The difference with these two statements, if this is the first time you're seeing it, in mathematics, we do a greater than with a line underneath, right? We can't really do that on a computer screen. So the workaround in all languages is they put less than or equal to, or greater than or equal to, and it reads pretty logically. But these are the basic comparisons that we use to do most if statements, right? Right. So here's an example. Here we have looks kind of like our Kahoot. Now you guys know where I borrowed it from, right? Yeah, that's where I borrowed it from. So we have a variable holding 33 in letter A, and B is holding 200, right? And notice here, single equal sign, right? So this means this is a value being stored in the variable called A. Then we get down to the if statement. We use the keyword if, and then we say, if B is greater than A, which it is, that's true, then we have a colon at the end of the statement, and then notice the indent. And I think I mentioned this in the Kahoot too, that Python requires a minimum of 2 spaces indented, making this print statement part of that if statement. Without the indent, it is not part of the if statement. And that's really, really critical. If you have multiple statements, they must all be indented the exact same amount. So if you decide it's 4 spaces or 3 spaces, it's got to be consistent, right? All right, so since this statement is true, this statement will execute. You can run the thing if you want to test it, right? Here's an example of the one that this is, I think, the exact same one that I used in the Kahoot, right? And it did trick a few people because this one is not indented. It will still print this out, but not because of the if statement. That's the weird part of it, right? So it has to be indented to be part of it. All right. What if you have more than one condition to check? So this is where we do what we call else if. Notice in Python, if you know other languages already, they say ELIF. Very weird. This is the only language that does this, but this is how they do it. So just roll with it. Okay. You know, took me a long time to get used to it. I'm used to it now, right? So the way that this one works is we're checking to see if the first statement is true. All right, and let's look at the conditions here. A is 33, B is 33. So if B is greater than A, that's false. That is not true. So we're checking this condition, and it either resolves to true or false. If it was true, we would execute this code, but it's not. So we are not executing that code. Instead, we check the second condition to see if A is equivalent to B, which it is. Therefore, this is what will output. So if you run this, if you do the try it yourself, you will see exactly that result. But the way that these statements work is we establish the if, we check to something, see if something is true or false. And if it is true, we execute the statement or we move on. There's also the else, right? So let's take a look at this one. The else will execute regardless of if there's a condition set for it or not, right? So, and if you notice in this statement, there's no condition set here. So let's check the logic. A is equal to 200, B is equal to 33. Is B greater than A? False. Yeah, that's false. So that's not going to happen. Is A equivalent to B? Also false. That's not going to happen either. With the last one, we are not checking a condition. Else will automatically execute. So this is what it's going to say. There's also a little bit of an algorithm going on here too. I don't know if you guys are picking up on this. We're determining if A is greater than B, right? Yeah, so this is where the logic comes into play. All right. Right. It's also possible, and I would probably teach this one first, before I taught else if, but whatever. You can also do this. You don't have to have multiple conditions you're checking. You can just check one condition, and if it's not true, then you can just run the other condition. This is the classic fork in the road. So if I go back to my pizza and mac and cheese example, I would say if dollars in pocket is $20 or more, right? Greater than or equal to 20, then we order Pizza Hut. Else, we're making mac and cheese or bologna sandwich or whatever you have on hand, right? So look at the logic here. Is A is 200, B is 33. Is B greater than A? False. So not happening. So this one happens automatically, right? So that's the general lay of the land. Now, as we also saw, by the way, and we didn't see this version of it. This is called, a shortcut way to do an if statement. So if there's just a singular action, I can write it all on one line. I don't have to indent it. This is kind of unique, right? So Python kind of breaks its own rules at times, but this does work. So if something is true, go ahead and print this statement. Notice there's no else. There's no else if, right? This just happens. This is actually pretty useful quite often. So sometimes it's like, hey, if the user's logged in, put their name on the screen. Okay. If they're not logged in, don't worry about it. There's no else, right? So this is kind of a nice shortcut way. There's also the if else approach on one line, and this is the one that we saw in the Kahoot verbatim, right? So this is the action you take if this statement is true, and this is the action you take otherwise, right? So print A if A is greater than B, else print B. This is very short and concise, and once again, helpful if you have very simple singular actions that you're taking with the user. I do see people code like this quite often, and it's pretty elegant because normally this would take 4 lines of code. This is 1 line of code. It does the same thing. It doesn't save on processing, but it sure saves space on the screen. So that's the primary reason I think to do it. Notice that this technique is called ternary operators or conditional expressions. This is kind of a modern programming technique, by the way. You can also kind of ramp up that technique. I'm not really super worried about it right now, where you're embedding an else if in there. That's really what this is. Not really worried about that, but I am worried about this one. And this is talking about the and keyword, where sometimes when you run an if statement, you're checking more than one condition. Here's the thing that often happens when you're doing this. Sometimes you have a bunch of conditions you need to check. So you might say, if A is greater than B, and B is greater than C, and C is greater than D, and D is greater than F, and whatever, you could go on. But whenever you see that keyword and in the mix, this implies that all of the conditions that you're checking must be true. If only one of them is false, the whole statement is false. Right? So that's when to latch onto. The converse to that is the or. With the or, only one condition must be true for it to work. So let's take a look at the example here. A is 200, B is 33, C is 500. Is A greater than B? Yes, that's true. Is A greater than C? False. However, this is an or. So either this one needs to be true or that one needs to be true. Since this one is true, the statement is true, and we're good. We would run this code. So these kind of statements, the ands and the or, this is where you really kind of have to map stuff out. So for example, going back to the rock, paper, scissors examples with the 2 5-year-olds, you know, I mean, if rock and rock, right? What's that? A tie, right? Or if paper is paper and rock, right? Paper covers rock. I don't know. These are kind of things that you start to think about and you start to map it out in your head, right? So if it's not, paper beating rock or rock smashing scissors, you have to kind of logic it all out. And sometimes you have to think in ands and ors to get that in. So some people will take the whole rock, paper, scissors scenario and make it one statement. It's not really the most logical way to do it, by the way, right? So they might write a statement like, if rock does not equal rock and paper is, one person chooses paper, the other one chooses rock, the other one chooses, they go through all the scenarios and they put it in one statement to determine that rock smashes scissors, when the smarter way to do it is to logic through each one separately with separate if statements. So these are weird little constructural things that you have to do. All right, those weren't great examples, but hopefully when we code, it'll make more sense. You can also use the keyword not. This is kind of weird, right? So this is basically the negation of whatever this is. So is A greater than B? No. If it's not true that A is greater than B, is that true? That's true. Another way to do that, by the way, is with an exclamation point. I could put an exclamation point in front of the statement if it was inside parentheses. Not a preferred way to do it, but that is possible in Python also. The other concept that we will look at, and it might not happen today, is this concept of if statements inside of if statements. So for example, if I have this statement be true, so x is 41, is x greater than 10? True. So we're going to print above 10. Then we check to see, is it greater than 20? That's also true. So also above 20. But if it wasn't, then the else would print out. So this is, what we call nested if statements, and those can go many, many layers deep. How deep? As deep as your mind can imagine. Also with compound statements where you're doing ands and ors, as deep as your brain can handle thinking about it and writing the code for it, the language will handle it, right? I do see some practical limitations to that. The one last piece that I'm going to throw into the mix here is the pass statement. So if you're in the midst of constructing an if statement, but you're not sure what the action is yet, you drop in pass. It keeps your code from failing in the IDE and it'll still work until you come up with what's supposed to go there. But basically what it does is exactly what it sounds like. It says, okay, well, whatever, bye. Just moves you along. All right, folks, that's all the luxury stuff. We're going to take a 5-minute break and then we're going to come back and code. So see you guys in 5. Welcome, everybody. We're going to get back to coding here. And we have 3 exercises to try to get through tonight. And so I'm going to put the description for the first one right inside my spider here. In fact, I'm going to kind of delete all this silly junk up top here. And you can see I'm fumbling with my mouse a little bit, but whatever. All right, so we're going to delete all that stuff, and here come the instructions. So write a program that reads an integer and prints whether it is negative, zero, or positive. And this, real frankly, is kind of a classic programming problem, right? Very simplistic, but kind of interesting at the same time. Remember, this is all a gateway to learn about if statements. So we're going to experiment a little bit. Now, the fact that it says reads an integer means that we're going to prompt the user for it. So I have one that's a little prompt here that's pre-prepared, right? And so we're going to ask the user, hey, enter an integer, right? We know what an integer is. Sometimes users don't. So you might want to tell them. I'm not really explaining it here, but basically that's a counting number, right? And this makes sense, right? We don't want people entering in floating point numbers in this circumstance, I don't think, right? And you could make an argument one way or the other on this. But I'm taking the input and I'm converting it to an integer, storing it in a variable called num, and then we're going to process the output and put the results on the screen kind of in one step. So we're going to do the processing and output together. So the processing will lead to the correct output. So let's have this discussion. How do I know if a number is positive, a positive number? Well, all right, that's kind of an easy one, right? That would be above zero, right? So if it's below zero, it's negative, right? And we're being asked here to indicate whether it's negative or positive or zero, right? So I'm going to do the positive one first. I like to think positively. At least I think I like to think positively. And so I'm going to say if the number is greater than zero. All right. I'm going to put a colon at the end of the statement. Now notice what happened here inside of Spider. I pressed enter at the end of the line. It knows I'm typing an if statement. What did it do? It automatically indented me 4 spaces. That's the default for this IDE, right? So if the number is greater than zero, I'm going to do my output. I'm just going to say right off the bat, print. The number is positive. All right. Makes sense, right? You know what? Can we test it? Now it's kind of silly to test at this point, but maybe not. So enter an integer. All right. Here I am trying to break it right away. -5. What happened? It worked, but it didn't give me a print statement because this wasn't true, right? So the number was not greater than zero, so it did not give me the print output. All right, let's run it again. This time I'll put in 0, which is not greater than 0, by the way, right? So once again, no output. If I put in a number that is larger, right, and then this makes sense. The number 1 is larger, right? The number is positive. All right, so we got the first part of it working, right? It's not being deceived by negative or numbers or 0. But now we need to do a second condition check. So with this, I have to go back to the margin. You notice I was at the end of the line and I pressed enter and it went for an indent again, thinking I want to do more actions here. I don't. So I'm going to backspace back to the margin to do my else if. So here I'm going to do else if the number is equivalent to 0. What will I print? Print. How about the number is 0, right? Because it's equivalent to 0. If we want to add the third possibility right away, once again, back over to the margin. Now I'm going to add the else statement and the colon, and this one will process no matter what. So if the number is not positive and the number is not 0, do I need to check if the number is less than 0 to determine if it's negative? The answer is no. It's automatically negative, just logically. If it's not 0 and it's not positive, it must be negative. I don't need to check it. And this is really kind of maybe the important part of this is when I don't need to check it, it saves a processing step. It's not reading something from memory, comparing a value, and therefore the program will run faster when I'm not doing the check. So I don't need to do the check because I know just from logic that it must be negative at this point. Yes, Martin.
Is there any point in checking whether the response is empty? Just a carriage return?
Well, you know
Or would
what?
that be too advanced for?
I'm going to say that's beyond the scope of the class,
Got it.
but
Got it. That's fine.
but that is a valid consideration though, right? So
Okay.
what if, and this is, one of the things you can use if statements for, what if the user doesn't type anything? Okay, let's take it even a step further. What if they type in their name? Right? Those are scenarios. I mean, we're not really ready to code for that yet, but that's a perfectly valid concern. And I'm going to say there's probably more elegant ways to handle it, but it still is resolved by analyzing a true false condition. So, for example, if somebody decides to give us bad information, right, non-numeric, okay, so we can have a thing that says, okay, if the user is telling us non-numeric information, what do we do? And the answer should be prompt them again, maybe a little more sternly this time, right? And then if they're putting the numbers in a format that's not valid, prompt them again. And the word again is really the key word here. So normally I would handle that with a loop is how I would do that. So if the user's not responding appropriately, I would just keep asking them at least for a certain number of times. Maybe I would like put a little counter in there and say, after 5 tries, too bad, too sad, goodbye. They can't figure it out after 5 attempts, then we got a problem, right? For example, sorry, incorrect password, try again. You want to give them an infinite number of tries? Probably not. Right? Yeah, but the moment that we have the ability to ask these coding questions, right? And let's put in a negative number now and see if it picks it up. And then, you know what, really the best way to do this is to test every scenario. And let's put in a positive number. And it doesn't matter how big or small the number is. Hopefully it works correctly. So this would be the first exercise working correctly. Now, just to show you, right? Enter an integer, Tom. Okay, well, this is what you get. So could I write code to accommodate for this? Absolutely. I could write code that just basically said if it's not an integer, I just goodbye, you made an error, and we haven't learned looping yet, but that would be kind of the scenario. All right, so this is exercise 1. None of you burned me on the fact that I forgot to do a save as right at the beginning. Right, I'm just calling you on it because there are times when I do forget. There was an example. It will never, ever, ever happen again, by the way. So this is going to be putting this in the unit 3 part 1 folder, and we're calling it exercise 3.1. Exercise 3.1. All right, that's the first exercise, folks. Let's move on to the next exercise. So I'm going to create a new file. Not going to catch me this time. This is a save as. All right, so this is exercise 3.3. And zooming in. And then as I did with the previous exercise, I'm going to drop in the instructions here. Here's the instructions for this one. So it says, write a program that reads an integer, so prompting again, and prints how many digits the number has by checking whether the number is greater than or equal to 10 or greater than or equal to 100 and so on. Assume that all integers are less than 10 billion. And if the number is negative, first multiply it by -1. Okay, so this is like a much, much deeper ask, you guys have to admit, right? So we got a bunch more to check here. And I will tell you that if you're kind of an entry-level programmer and you're presented with this problem, this one might perplex you as how to solve it. So that you'll be thankful that I'm helping you walk through it. Now, I do get people that know how to figure this out, but typically those people have already learned how to code, right? And that's not unusual. So I'm going to start with like the basics, the most basic of basic things. And the first basic thing that we have to do is just get our number from the user. And yes, I'm just going to copy and paste that in. So I have a prompt that looks like the one from the previous program, right? So we're just prompting the user for an integer, but I'm giving it a qualification less than 10 billion. That's our limit on this, right? Why? Because I don't want to have to check infinitely large numbers. But you notice what they're doing here is you're going to be doing a comparison against basically the number of digits in the 10 base 10 number system, right? So the program's going to print how many digits the number has. So how do you do that? Well, I know how I would do it visually. I would just put the number on the screen and count. I would go 1, 2, 3. Look, it's got 6 digits, right? But how do we get the software to do that when I haven't learned that I can actually count the digits in a string? So one trick, and we'll learn this later, is that I can just take a string as it is and run the length function, and I know what it is, right? So that's really like what a regular programmer would do, but that's not the assignment here. The assignment here is to write a bunch of if statements to figure this out. All right, so now we're going to do a little bit of figuring, and with the way that I kind of did it last time, and I am copy pasting from there to make it go a little bit faster. All right, so we're going to do some processing, and it does say here at the bottom, it says if the number is negative, first multiply it by -1. To me, it sounds like that should be the first step. So that's what I'm going to do. So I'm going to write the little script that just checks to see if it's negative. So here we go. If the number is less than 0, well, it's negative, right? And I'm not going to do a print statement at this point. What I'm going to do is I'm just going to take that number and store it back in number, but I'm going to multiply it by -1 first. So I'm going to do num times -1. So if the number happens to be negative, if it's less than 0, we multiply it by -1. It cancels out the negative. Now I can count the digits. So what they're saying is they want to count the digits, but they don't want to count the negative sign as part of one of the digits. So this effectively gets rid of that. There's also, it's probably notable to say this, there's also a mathematical function that we could use to do the same thing, and it's called absolute value. That's what, and I'm trying to abstain from using the absolute value function to do that. So we could just run a function and do the conversion, but I'm just doing it with math because that's basically what that function does. All right. So if I'm going to count the number of digits, and I'm going to ask a bunch of if statements. So for example, they're suggesting, and I'm not saying that this is really the smart approach. And in fact, I've figured out over the years, I think the author made a mistake when they put this together. It says by checking whether the number is greater than 10, greater than 100, and so on. So think about this. If I have a number, and this is just an example, mind you, right? So if I have a number and I type 1, 2, 3, 4, 5, how many digits are there? Well, there's 5 digits, right? So put them up there and numbered them for you, right? But if I was to look at a number that was greater than, what's the biggest 4-digit number I can have? All right, make it all nines, and it would be 9,999. That's the biggest 4-digit number I can have. I add one more, I have 10,000, it becomes 5 digits. So that's why I thought the author's logic was a little weird, right? So what they're saying is if a number is greater than or equal to 10, then it therefore has 2 digits, right? And if a number is greater than or equal to 100, it therefore has 3 digits. Well, that kind of works, but here's where that logic breaks, by the way, if you think about it. If I have a number that's greater than or equal to 100, but it's got 5 digits, would I write an if statement that says if it's greater than or equal to 10, it's 2. If it's greater than or equal to 100, it's whatever. And if you think about the thing I taught you during the Kahoot, which is like whichever condition hits first that's true, that's the one it's going to be. So this is kind of the right logic, but in the wrong order. This is what, and this is, I don't know if this is an intentional trick from the author to try to get you to figure it out. And I think maybe that's it, or if it's just a typo, because there's really kind of a better way to do it. And that is to reverse the sign, get rid of the equals, and check to see if something is less than 10. Because if it's less than 10, I know for sure it's a 1-digit number. You see my thinking? So here's kind of the logic that I'm thinking. And so I'm going to put in this comment here, and I'm going to move it down a couple lines. But I also asked this question: if I start storing the number of digits for display on the screen, do I want to set up a variable to hold that value? Okay. And then I'll even ask the question, do I need to do this? And basically in advance is really what it is. So I'm setting up a variable container and presetting it to 0. And then depending on what they type in, I'm going to reset it to the correct value and then put it back up on the screen. And so I asked the question, do I need to do this in advance? Now, the answer to this, by the way, and I'm going to say answer equals no. And this is kind of weird for people that have done regular programming before, because normally it's like, hey, if I'm going to store it in a variable, I got to declare the variable first, declare its data type, etc. Right? That's what we would do in Java or C#. Python kind of doesn't need this, and I'll show you why in just a moment. But I'm going to comment that out, so I'm just removing it as code. Right. So here's my first if statement. So if the number that we captured is less than 10, and mind you, I'm reversing this logic, right? And this is the logic I figured out over the year. Then the number of digits in the variable I'm calling digits is equal to 1. So think about it. If I type in 0, would that work? It's 1 digit, it would work. If I typed in -1, it would first become a negative removed 1, and then it would become 1, and that would work too. So any negative number that's truly 1 digit would work as well. Any positive number that would work as well. So anything between 0 and 9 that I would type in would work. Now I keep ramping this up, and this is kind of where the logic gets weird, because I can do this 2 different ways, and both, by the way, are perfectly valid. So one approach would be that I have a series of discrete if statements that do this. Okay, so think about the logic on this. If I type in the number 22, is it less than 10? Nope. Is it less than 100? Yes. The digits equals 2. So you see how I think this is deceiving in the description, because it forces you to think about it. Now, it is possible, and I have had students do it, that reverse the numbers in the opposite order and then build up, basically. And basically what we're going to do here is we're just going to take this code and just keep adding zeros and changing numbers. And should they be separate if statements? Does this work? All right, let's try 22. No, we don't have an output. I guess we should probably engineer an output statement. So let's do this. Here's my output statement. Let's put it at the bottom. The number you entered had X number of digits. All right, let's run it again. We'll do the same code. And this time we'll put in 55. Is it correct? It is. Let's try a single digit number. Why did this fail? Okay, Martin I think you're going to point out what the flaw with this logic is and why I need something else. Go ahead, sir.
No, maybe I'm I will confuse things more, but one thought of one approach I thought was the use of less than, you're going in this from minimum to maximum, from
Mhm.
lower to higher, then use less than, less than equal, less than equal to the 9 and 99 and 999, and so
Yeah,
that gives you a visual of the or the number of digits. They stay, anyways. That's
yeah, no, no,
I,
I see where you're going with that, and that's a perfectly valid approach, right? It's a matter of whether you include the highest digit number of that value or whether
yeah,
you're
that's
not. I mean,
same
that's really the
thing, but
difference.
okay.
Now, isn't this interesting though? What happened here is I put in the number 5 and it's telling me it has 2 digits. But if we follow our code, it went in here and this is true. So it set it to 1 digit. But you know what? This is also true. So it set it to 2. So really, I need to do an else if here. So let's now try to run it.
Oh,
You
I
see,
see.
you see
Yeah.
the difference, right? So
Yeah.
I'll put in 66 this time and notice now it's correct. But if I do the number 3, now it's correct with 1 digit. So now knowing that else if is the more logical approach, here's the more logical expansion of this code, right? So once you have your pattern established, I can come in here and keep expanding this. And yeah, I'm pasting in a whole bunch of them. I don't even know how many I need quite yet. Probably about 10 of them, I think, something like that. Notice how this one breaks without the indent. And then I'm going to go back and I'm just going to keep adding zeros. And I'm trying to keep track of that's hundreds, thousands, and that's 10 million. So we need, and then we can change our digits here. And you see, like my strategy here is I paste it all in and then I do my tweaks. Now, this is just kind of like an efficiency of data entry. And you might opt to type it all out. And that's on you, real frankly, if you want to do it that way. And I think I need one more. And this last one, I'm just going to copy and paste it in since I have it available, except it pasted horribly. And I see why, because I copied it horribly. And then, Martin, I'm going to go back to answering one of your questions here. And so I actually have to go beyond here to get to the 10 digit level. But what if they enter in a number that's bigger?
Mm.
We didn't even think about that because you know you'll get some wise guy user that will probably do that. We can also, at the very end of the whole statement, drop in a regular else statement and we can change. See, this is the beauty of Python, folks, right? Because we're outputting this, right? I'm now switching it to a string and I'm just outputting text instead of a number. Isn't that clever? Right. Welcome to Python. Right. Can't do that in other languages, right? You'd have to write an if statement to be able to put the text on the screen. So we are just saying, hey, this has more than 10. Now what's left to do, folks, is to test. So let's get to the testing and set up the console here. I'll leave that code on the screen. Of course, you guys can screen capture it if you really need to. I'm going to move this over a little bit. So we need to enter an integer less than 10 billion. All right, let's put in a 3-digit number. All right. And once again, we don't have a loop, so we can't let the code run over and over again. And so like what you can do here literally, and one of my favorite ways to do this is to like just number the digits as I'm putting them in. You just go right up the number keypad, basically. And by the way, you can do a negative number and then go up the keypad. Oops, except in the wrong spot. Sorry. Yeah, it's called user error. Prepare for it. But it seems to be working okay. Let's get it all the way up to that 10 billion number, which is 9, 10 zeros, right? So, all right. Because it does say less than 10 billion. So would 999 yada 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 like that version of it work? So let's just do that. There you go. Now, if you, because I know some people do these in advance, so if you came up with a different way to solve it and it still works, I am perfectly okay with it. Because really, this is kind of an exercise of two different things. It's an exercise in logic, right? And engineering the statements as well and getting it to work. Now, would this have a practical use in real life? No, probably not. But it sure does teach you how the if statements work, right? And more importantly, it's giving us the correct answer, right? Regardless of what's going on underneath the hood. Okay, so that's exercise 3.3. Right. We are now going to move on to the next one. So another new document here and doing the save as. This is exercise 3_12. I'll zoom in here on the code. Once again, I'm going to drop the instructions up here since I have them. And this one is a little bit more complicated also, which means it makes it a whole lot more fun, right? That's kind of the way I see it, right? You know, you can play checkers or you can play chess. I guess I'll opt for chess most of the time. Right. So let's read what this one does. This one says, write a program that translates a letter grade into a number grade. Letter grades are A, B, C, D, and F, followed by a plus or a minus. Their numeric values, respectively, are 4, 3, 2, and 1, and 0. And isn't that how coincidentally they lined up here? just like I planned it, right? Not necessarily would have worked out that way. There's no F plus or F minus, and A plus A plus increases the numeric value by 0.3 and a minus decreases it by 0.3. However, an A plus has a value of 4.0. So there's really no A plus in the grading system. And how timely, right? Because we're going into midterms. And remember that your midterm grades don't stick on your transcript or affect your GPA, but your final grades do, right? And for a lot of students, you know, the GPA is like huge for a lot of people, right? And I can tell you from my own experience that, you know, like in high school, I was nowhere near a 4.0 student. I was like barely near a 2.0 student. So there is hope for you if you were a low achiever, by the way. All right, so this is a lot more complex kind of problem because first of all, we're trying to take letters as an input, evaluate the letters and special symbols that follow, and convert those into numbers, and then put the correct grade up on the screen on top of it all. This is a little bit deeper lift than what we've done so far, right? So please follow along with this. There's a bunch of new concepts I'm peppering in here. So we're going to take these once again, one at a time for analysis. First thing that we're going to do is we're going to prompt the user to enter the information. So we're just going to say input, right? Enter a letter grade, use capitals. Of course, some people won't, right? But we ask. Notice there is no conversion here to numbers because we're asking for a letter grade, right? So we don't want to convert. So we're storing it in a variable called letter. All right. Another thing that we need to do, right? Well, I asked politely for uppercase, right? But, some people have their cap locks on or are intentionally trying to break your program, because there are people like that, right? And so what we're going to do is we're going to add what we call a method to the letters that we've captured from the screen. And this is, how do we know this is a method? Because of the notation of it. So in other words, whenever you see something that is of a certain object type and the information we just captured from the user is basically a string or a series of characters from the keyboard. Strings as a special structure within Python have a number of method functions attached to them. One of them is uppercase, which takes whatever letters you put in, and these are letters from A to Z, and converts them to uppercase. There's also, you might guess, lowercase. I'm choosing to work with upper, but if I could choose either one. But the reason I chose upper is because when you look at a report card, they're always in uppercase letters. That's the why, right? Also, if I was writing code to check, okay, so like the person enters the letter A, I don't want to have to check for uppercase A or lowercase a. So I don't have to say if grade equals capital A or grade equals lowercase a, it saves me the hassle of checking twice, therefore making for more efficient code. See the logic there? Yes, Alex.
Could you just put the dot upper right after the input at the end of the line?
You could. So what Alex is referring to here is, could I put dot upper here? Yeah, you could do it there. And you know what, Alex? I don't like to throw that concept in there because that indicates to me that you're already an advanced programmer, right? Advanced programmers would exactly make that move. Why? Because I can write one less line of code. But when I do it this way, you're seeing that step happen, so it makes it clearer, right? And then I can highlight it. And then I usually add this little comment at the end as well, right? So we're converting, so we don't have to check. So you only have to check once, right? Upper or lowercase. The next task that we're going to do is we're going to take the letter portion of the grade and convert it to a number. Now here's our scenario, and I want to kind of like point this out. So we're going to have this prompt that comes up on the screen. It says enter your grade, and somebody might type in, B. Okay, that's great, easy, right? Because I can say if letter equals B, you have a B, you have a 3.0, right? But if they say B minus, well, now I got an issue, because all of a sudden I'm not just getting a letter, I'm getting two characters on the screen. All right. So I'm going to revert to spreadsheets, and you guys are like, what the heck is he doing? Yeah, I'm going to bring up my spreadsheet program because this is my favorite way to kind of demonstrate this concept. And so I'm kind of zooming way in on my spreadsheet here. And this is like really kind of goofy, nerdy stuff, right? I'm using the spreadsheet because it's a great tool for doing this kind of thing. And we're going to be working with really basic info like letters, right? And I consider this my variable name. And then I'm going to number these cells. And experienced programmers already know what I'm doing, right? Inexperienced ones will be like, what the heck is he doing? And I'm about to tell you, by the way. All right, so I'm creating this like little like visual here to kind of make a point. Whenever we type in words on the keyboard on a computer, like this, The reality is a string of characters, when they're stored in a variable structure, each individual character is going into its own memory storage location. This is really bizarre. But collectively, all of those storage locations, which are numbered, are part of the letters variable. The power of this is I can focus in on any one of the letters individually in memory and contend with them as separate objects. This is pretty cool. So for example, how do I do that? So if I say letters square bracket 0, that's basically equal to W. It's a character. Or if I say letters square bracket 1, I'm accessing the O. Right, so that's where this stuff is at. So interestingly, the first value, or the index number, this is what these are. This is an index. The index always starts with 0. Computers always start counting at 0. If I ran the length function, so if I said length letters, this would give me a result of what? What's the length? 4.
4.
Right. Which is one higher than the highest index number. These are kind of really interesting things. So if I wanted to look at this last number, and we'll talk about this more as we kind of move forward, there's a number of really clever ways in Python to do this, right? So normally, sometimes we'll say the length of the array minus 1 gives us the final position, right? But this is the part that we're really concerned with right now, is if people type in a grade, they might just type in a letter, but they might type in 2 characters. They might type in A+ or D- or C+, that kind of thing. So we're looking at those first 2 characters. So this is necessary to explain to do this next part of the program, because otherwise we cannot do this task, right? So let's go back over to Spider now and kind of put this into effect. All right. So here's how we're going to write this. So I'm going to say, if the letter that we've captured in position 0 of letter, the first letter, is equivalent to a capital letter A, then, okay, well, now we got to think about this. What are we doing? We're converting the letter A to a grade, right? So let's put in a number variable to hold that, and we're going to set that to 4.0. So if the letter in position 0 of letter is A, we're setting the grade point to 4.0. Now, a couple things I'm going to throw in as a wrinkle here. If I had not completed this line, so let's say I block this out with a comment mark, and the user typed in a lowercase a, I would also have to put in an or here and say, or the letter in position 0 is equivalent to a lowercase a. I would have to do that check on every single one. Uppercase A, lowercase a, uppercase B, lowercase b, uppercase C, lowercase. Get my drift? So that's why this is really useful. So I don't have to do that. I'm going to leave this one here because it won't break anything, but that's just an example of what I might have had to write for every statement, but I'm leaving that out because I'm converting everything to uppercase here. And then if you want to be extra clever, you can take that upper method and just add it right to the input statement, which a lot of programmers do actually do. You tend to have a little experience under your belt first, though. From here, we go to an else if, and then we're just going to kind of follow our pattern here. And we're just going to use the same syntax, right? If the letter in position 0 is a capital B, then num will equal 3.0. Now, some of you might be asking, well, what about the plus or minus? Well, we're going to deal with that separately as a separate thing, right? So we're going to keep following this pattern here. We're going to put in C, and that num is going to be a 2.0. Else if the letter is a D, oops, that's going to be 1.0. And then, of course, else if that letter is an F, then that value is equal to a dreadful 0. Right? And, okay, so here's the what if. What if they don't type A, B, C, D, or F? They type E or Z or, hamburger or something like that. What do you do, right? Well, then you better have an else in here. So the else will happen no matter what. If they type something else, well, that's still an F, sorry. So else, if it's not that, you still got a 0. I got a Z. Yep, that's a 0 too. Congratulations. Right. Hopefully you guys never get grades like that. All right. All right. So that's the first part of the logic. And you know what? Remember, we're trying to convert the letter grade into a number, right? So it would be helpful to see if our logic so far is working. So I'm just going to do an output statement just to test what we have so far. Here's my output statement. I'm going to slide it down a couple lines here. Here's the paste. It says display the result, print the numeric value is, and notice I am using a wildcard and I'm placing that into a string. Do I have to do it like this? No, but I'm just kind of using it, whatever. You could just do the numeric value is comma num. That would work too. Okay, so here goes. Let's run it and see what we have so far. So I will put in an A. Okay, great. I will put in, and ideally you would test every letter, but let's put in a V. Okay, still get a 0. Right. So hopefully, and I would have you ideally, like I said, test every A, B, C, D, and F just to make sure that they all work. And I'm just doing some of them. I'm assuming mine's going to work fine now. Right, so here's the output. All right. Now we have to contend with the other part, which is the plus or minus. Right. So we're going to write a separate series of statements for this. And then I'm just going to add a little comment here if you find it helpful, by the way, right, which some of you do. So we're going to handle the plus or the minus if it is present, right? We're going to use the same kind of approach here, and we're going to check now real carefully if they typed an extra character. First of all, how do I know that? This is a weird question, right? Okay, so now going back to this goofy spreadsheet I did, well, we can check the length of the variable to see how long it is. So if there's more than one character, so if the answer is like 2, well, okay, well, let's check the second character, which is in position 1. All right, so that's kind of the general logic of it. So let's write that part of it. So I'm going to say if the length of letter is greater than 1. Or do I want to check for a specific amount? Well, I don't know about that, but as long as the first 2 letters are okay, I don't care how long it is. That they can type A plus and then supercalifragilisticexpialidocious. I don't care. As long as the first 2 letters are correct, I'm fine with it. Right? You could have arguments about this, but this is how I'm going to do it today. Right? So if the length of letter is greater than 1, and then there's another scenario here too, and the letter in position 0 is not, and you guys might not think of this scenario, is not the letter F. Because if they got an F, plus or minus doesn't matter anyhow. Right? There's no F minus or F plus. Sorry, an F is an F, is a zero is a zero. So that would be excluded. So it can't be an F, and it has to be greater than 1 in length, at least 2 characters long. So if that's true, are we done checking stuff? Okay. And the answer, once again, is no. All right. So now I got to check to see if the letter in position 1. So in other words, if you're doing the comparison, it's the second position. We're looking for a plus or a minus this time. So what they might actually enter in reality is like B plus, and the plus is a character, right? So this is the one we're trying to focus on. So we're looking, and I call this letters, but it should be letter, whatever. So we're looking for letter position 1, right? So we're going to say if letter position 1 is equivalent to plus, okay, another scenario though, and letter position 0 is not equal to capital A. All right. So what I'm doing here is I'm saying you can use a plus, right, to add value to your letter, but not if it's the letter A. That one's not allowed. Right. So this is kind of the clever logic way of doing this. And then if this is all true, then we're going to take that number and we're going to take the number and add 3 to it. And actually, excuse me, 0.03, 0.3. So if you get a B and that's worth 3, if you have a B plus, it's 3.3. Okay. So now I'm going to talk about this statement because here comes another teaching point. And that is, this is one way to do the math. So if I want to add a number or add a value to a number I already have, I take the number, add the value I need, and then put it back in the number, right? So I'm adding 0.3 to the number and storing it back here. Or, and there's probably what the experienced programmer would do, by the way, and I'll actually make this the comment, is what an experienced programmer would do is they would use the compound operator here and do this sort of math, which is the same as saying this statement, right? So if I want to add a number back to itself, I can simply use this compound operator where I say plus equals, which means I'll take whatever's here and add it to the value that's already here. This is a really convenient modern way to do this. Either one works just fine. Experienced programmers almost always go for this approach. Right, so that's adding the 0.3. There isn't other scenario though, right? I'm going to come back one indent level here, and I'm going to say else if the letter in position 1 is equivalent to minus, right? Because we didn't do the minus one. Then the number will be minus equals 0.3. So this one is detracting. So if I get an A minus, it's 4 minus 0.3, so it's 3.7. Right, so this covers all the scenarios. Is there an else in this scenario? There is not. Right? Those are the only situations in which we would use any of that. Now, the other thing that I'm going to give you is kind of like a point of logic on this, because this is actually a fairly complex if statement. If, like I said, if I left you guys on your own, the ones that have coded before would probably figure this out. The ones that had not probably wouldn't, but there's so much content and depth on what we just did here, I would have you reflect upon it maybe a couple of times and review the code and follow the logic. This part I think was pretty easy. Once we figured out how to get the first character, right? That gets the first character. And then you just compare the first character. And if you have it, you assign that value. If that's not the first one it catches, yeah, go ahead.
I don't think we handled that. You don't subtract a 0.3 from an F. Or am I mistaken?
Well, okay, so follow this logic here. If the length is greater than 1 and it's not an F, then we can check for plus and minus, George. Right. So this is like exclusionary logic. It's not even part of the equation, right? If it is an F, then both statements aren't true and it wouldn't execute. But great question though, right? Because it almost seems like we're missing it, but we're not. All right, let's run this and see if it actually works. All right, so enter. All right, so I'm going to try an A because that's what I deserve, I think. No, I'm just kidding. Let's try an A minus. Let's pick one at random here. Let's do C plus. Let's do a D minus. Let's do an F. Okay, let's test the F plus. No help there. Let's do an F minus. Let's do what the heck ever. That's still an F, sorry. All right, so I think we've proven that it works, right? And I think this is really kind of a neat little exercise. There's a lot peppered into this in terms of concepts. You know, some of the new concepts here are converting things to uppercase. I think we kind of did that before. Learning about the index values of strings, right? And then this what ultimately lead us to talking about arrays and lists and sets and things like that.
Oh.
And then the if statements, the else ifs, and then the compound statements, and then following through a chain of logic. Because really what's happening in these two lines is we're testing 4 conditions before we can execute even one line of code here. Right. And so if you put this in your brain and reconsider the whole rock, paper, scissors scenario in your head and what it takes to play that game, and the fact that a 5-year-old can explain it to another 5-year-old in 2 minutes or whatever, and they're playing, that's the kind of like thinking you have to do here. But then you have to break the steps down into little pieces. And if it helps, say the words out loud to logic through all the possibilities. If you can't reason through it in your head, make a diagram. That really works for a lot of programmers. I mean it very sincerely. Sometimes a picture is what it takes to kind of figure out the logic tree of this. What I do like about Python enforcing the indents, right? Because if you've ever coded in another language where you don't have to, you just do it because, you know, because it looks better. The indents really do help you see the structure of it too. All right, folks, I'm going to end this recording here. So these are the solutions.